is called the combined gas law. This means we're simply going to take the three equations that we just went over and combine them into one formula. So the three equations that we just looked at are not on the reference table. The combined gas law is. So all we're going to do is we're going to take the three values that we just talked about, or the three equations, and put them together. So in this one, P1V1 equals P2V2, they're together, right? Pressure and volume are together. Then this one, P1 and P2 are on top, T1 and T2 are on the bottom of the fraction. Compare that to our last one, V1 and V2 again are on top, and the T's are on the bottom. So in every equation that temperature is involved in, it's on the bottom. In every equation pressure and volume are in, they're on top and they're together. So when we take these three and merge them together, we get this equation. This is on your reference table. P1V1 over T1 equals P2V2 over T2. So thinking like a student who is algebraically inclined, meaning they have trouble using these types of equations, what do you think is the first thing that we need to do to make it easier, simplify it? If you have fractions on both sides of the equation, what does your teacher tell you to do? They tell you to cross multiply. So when you cross multiply, you're going to do T1 times P2V2 equals P1V1 T2, and you get this equation. Now, the reference table has it like this, yes, but I'm going to tell you, you need to memorize it like this. This is the easiest way to plug it in, simply because everything is on the same plane. But there is one common mistake that occurs year after year after year, and I'm going to drill it into your head not to do it. You have to be careful of your temperatures. Because we cross multiplied, that puts your T's on the opposite side. So we get P1V1 times T2 equals P2V2 T1. So you've got to make sure you have the temperature on the correct side that it's supposed to be on. Okay, we have three example problems that we're going to go over. And then you're going to do more practice as well with this. So the thing that you need to do is find all the values that are mentioned and label them. Okay, that's step one, is to go through the problem, dissect it, and figure out what it's telling you. And this is why it's extremely important to know your units of things, because it's not always going to say pressure is this. Okay, you have to recognize that torr means pressure. Okay, so a gas pressure is 765 torrs. This means this is P1. It's our first pressure mentioned, so it's our P1. Now, at that P1, we know it's at 23 degrees Celsius. What does degrees Celsius tell you? That tells you a temperature. So that's going to be our T1, because this is the temperature at this pressure. So they're together. Then, at what temperature? So there's our question piece. It's asking for temperature. So we're looking for T2. Will the pressure be 560 torrs? So this is our P2. Now, that's step one. Step two is whenever you have temperature in the problem, you need to make sure you convert to kelvins. So step one is to label. Step two, convert your T's. So this means T1 is 23 degrees Celsius. We need to change it to kelvins by adding 273. So when we add 273, we get 296. Okay. Okay, that's step two, is to convert your temperatures. Step three is to write your equation. P1 V1 T2 equals P2 V2 T1. Now, The thing with the combined gas law is it has all of the variables in there. But does this problem mention all of the variables? No, it does not mention volume. So, little side note here, the little star. Cross out any variables not mentioned or said to be constant. So cross out any variables that are not mentioned or said to be constant. So for example, volume is not mentioned at all in this problem, so we are going to cross out the V's. So when we cross out the V's, what is our new formula? P1 T2 equals P2 T1. Then we need to solve this equation for our unknown. So in this case, our unknown is T2. So to get T2 by itself, we need to divide both sides by P1. When we divide both sides by P1, those go away, and you get T2 equals P2 T1 over P1. Now all you have to do is plug it in. So our P2 is 560 times T1, which remember we have to use the kelvins, so 296, divided by our P1, which is 765. Now we are doing sig figs as well with this. So you're going to look at all the values that you plugged into the problem and go with the least amount. So with this 560, they put a decimal there. So we're going to put a decimal here as well. So that gives that 3 sig figs, 3 sig figs, and 3 sig figs. So your final answer should have 3 sig figs. And you should get 217 kelvins. Now, if I specifically ask for it to be in degrees Celsius, you would simply take this 217 and subtract 273, and you would get negative 56 degrees Celsius. But I didn't ask for a specific unit, so therefore just putting 217 is fine. Next, a gas occupies 100 milliliters. Okay, this is what I'm saying. You have to be able to recognize your units and be able to tell me what does that milliliter say. Milliliters tells you a volume. So this is our V1 at 150 kPa. kPa tells us a unit of pressure. So that is our P1. Find its volume. So we're trying to find V2 at 200 kPa. kPa is a unit of pressure, so that is our P2. So that's step 1, we labeled. Step 2, convert temperatures. Do we have any temperatures to convert? No, so we don't have to do anything there. Step 3 is to now take our formula and figure out what we need to do. So first off, you need to see if all the variables are there. Pressure? Yes. Volume? Yes. Temperature? Does it mention pressure? Does it mention temperature anywhere in the problem? No, so we cross out our T's. So we get P1 V1 equals P2 V2. In this case, we're solving for V2. So this is our unknown. How do we get V2 by itself? Divide both sides by P2. So then we get V2 equals P1 V1 over P2. P1 is 150 times V1, which is 100, divided by 200. Now there's decimals at the end of each of these values, so all of them again have 3 sig figs. So your answer should be 75.0 milliliters. Now your units for V, whatever your V1 is, that's going to be the unit for V2. So V1 is in milliliters, therefore V2 is going to be in milliliters. The last problem is the hardest. So if you have not been focusing on what's been going on in this video, you need to stand up now, shake it off, and pay attention to this practice problem, because I'm going to shove a lot of information into this one problem. Okay? And you will have one like this again. A gas occupies 7.84 centimeters cubed. So step 1 is to label. So 7.84 centimeters cubed is our V1. At 71.8 kPa. kPa is a unit of pressure, so that's our P1. 25 degrees Celsius, that is our T1. And there are no more numbers in the problem. So we have all our ones, so where are the twos? They're hidden in the problem behind 3 little letters. Okay, it says find its volume, so that means we're solving for V2, and then this guy right here is telling you your T2 and your P2. This is why it's important to understand what STP stands for. So if you have STP mentioned in your problems, you have to look on the front of your reference table, find the values that go with it, and plug them in. So STP, find its volume at STP. So standard temperature, you will always use 273 K. Temperature, standard temperature is always 273 K. That one you should be able to memorize fairly quick. And you don't even have to memorize it, it's on the reference table. Now the P's. Pressure is where students get it wrong, because you need to look back at the problem, look at the unit of P1, and use the same unit for P2. So in this problem, we're using kilopascals, kPa. So look on the front page of your reference table and find the standard pressure when it's kPa. And you should see that it says 101.3 kPa. Now, if you have no idea where that number came from, you need to make a note of it and ask me later. Okay, but it's on the front page of your reference table. So now, we've labeled everything. Step 1. Step 2, convert your T's. So T1 is 25. We need to add 273 to make it kelvins. So 25 plus 273 gives you 298 K. Now for T2. T2 we already have it in kelvins, so we don't have to do anything to that one. Step 3, figure out our formula. So P1 V1 T2 equals P2 V2 T1. Are there any variables not mentioned or set to be constant? No, therefore we are using all of the values this time. This is where the algebra can get a little bit tricky. Putting in the calculator gets a little bit tricky. You just got to be careful, make sure you're looking at what you're doing and putting the parentheses in the correct spot. So we're trying to find V2. So we need to get V2 by itself. That means we need to get rid of these two guys here. So to get rid of those two guys, we need to divide them on both sides. so they go away. So that means we get V2 equals P1 V1 T2 divided by P2 T1. So when we plug, we're going to put parentheses around the top times P1, which is 71.8, times V1, 7.84, times T2. Okay, this is the important piece. You've got to make sure your temperature is in the correct spot. Some of you get on a roll, P1, V1, and then you simply put T1 on top when that's going to be wrong. So P1, V1, T2. So your temperature, the second temperature is 273. Close parentheses, divide, times, open divide, open parentheses, P2 is 101.3 times T1, which remember, you can go back to this number, but you're going to get it wrong. You need to use the K value that you discovered, which is 298. Close parentheses. Give you a minute to plug it in. You're allowed, looking back at all the values, 3 sig figs, because when you look at temperature, you're going to look at this K value here. So that's 3 sig figs. And your answer should be 5.09 centimeters cubed. This is the end of the video. You need to look back at your notes and write down any questions, reflect on it, make sure you get each steps that you need to do going through the problem.